Welcome back, Mindsetters. I told you that would be a really fast break because there is so much for us to go through. And as expressed on the page, there's so many of you joining us today. I mean, we have grade 11s as well joining us. So welcome, grade 11s and grade 12s. Make them feel like they're at home and maybe help them out with the things that they haven't covered yet. Over to you, Peter.
Right, just before the break, we were looking at the way people get around and the different forms of transport, and we actually were astounded by the fact that 73.1% of South Africans actually walk where they have to go. That's quite something, hey? It really is. The other day, my son came to me and he said to me, "Oh, Dad, please will you give me a lift down the road?" And we're talking about 800 meters. And I looked at him and said, "My boy, let me tell you something. When Abraham Lincoln was your age, he used to walk 10 miles to school." And he looked at me and he said, "Dad, when Abraham Lincoln was your age, he was president of the country."
He
So
got
I put
you
him in
there.
the car and gave
Yeah.
him a lift. So it kind of
He
made
really
sense.
got you
Lost that one. Right, folk. We said before the break, or we started the series off by saying that we were going to give you a challenge question in this part of the show. And that's exactly what we're going to do. Before I give it to you, there are just a few things I want to run through very quickly to help you with this challenge question. And here it is. Okay, first thing, we've got to know, what is the range? You know this already. You're in grade 12. If you don't know it by now, you're in trouble. Okay, so the range is my highest number minus my lowest number. We know that, eh? So range is equal to, let me just get a pen here, is equal to my highest number minus my lowest. My median, we discussed this before the break, my median is my middlemost number. Okay, so if I give you a whole lot of data, you've got to arrange it in order from the smallest to the highest. Here's a bit of a hint, okay? So you're arranging the data from the smallest number to the highest, or highest to lowest. It doesn't really matter, but generally we tend to prefer lowest to highest, okay? So you arrange your data from lowest to the highest, and it's the middlemost number. Quartile, now let's go through this, because you were introduced to quartiles only this year in grade 12. So what is a quartile? Well, a quartile is exactly as the name says. It's a quarter of the information, right? So let's say I gave you 5 numbers. Again, we've got to arrange it in order, and that's the important thing to remember here. So if I gave you data, let's say 0, 1, 1, 2, 3, 3, 4, 5. Okay? And I wanted to calculate the quartiles. Now you get different quarters. You get the first quarter, the second quarter, the third quarter, and the final quarter. And so what we do is we break up these figures. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to give us another one. Let's say 5 again. Okay? So my median, 1, 2, 3, 4. Oopsie, what have I done? I've done something wrong here. I've pushed the wrong button. Something went wrong here. Where did it go to?
Did you lose it?
I lost it,
There.
eh?
Isn't it there?
Is it there? No, it's not. Let's go. Maybe it's here. Is it here? No, it's not there. Is it there? I don't know what I've done. I've lost the information. Okay, but let's just go through what quartiles are. So my quartile range is going to be, if I have those numbers, and we said let's pretend I've got numbers 0, 1, 2, 3, 4, and 5. Okay, my middlemost number, and let's give it a 6. 1, 2, 3. Oopsie, I'm really fooling around here today. Everything that can go wrong is going wrong with all this today, isn't it?
Yeah, Peter,
Okay,
I think
there's
it's
my
you.
information there. Right. So if I look at this, I've got 0, 1, 2, 3, 4. My middlemost number will be my 3. Okay, and this is my lowest number, and this is my highest number. This we call quartile 2. Because it's in the middle, right? And my middle, another word for my median, is my quartile 2. It's quarter, the second quarter of my information. The first quarter is that way, the second quarter is that way. But my quartile 2 is my middle. My quartile 1 is finding the middle of my lowest and my quartile 2. So the middle of this would actually be somewhere over there. And I call that quartile 1. Quartile 3 is the middle of the 4 and the 5. It's the middle of my quartile 2 and my highest number, which is going to be 4.5, and I call that quartile 3. My quartile range now is going to be quartile 3 minus quartile 1. So in this example, my quartile 3 would be 4.5. My quartile 1 would be 1.5. So the difference would be 3. 4.5 minus 1.5 is 3. So I land up then with a quartile range of actually being 3. All right. Now I've got to give you the challenge question, and here comes the real challenge for me. And the challenge for me is this, that I've just lost the challenge question.
I think it's there, hey.
You think it's there?
Just where...
Up here, no, it's not there. Up there, it's not there. Up here,
Nothing.
nothing at all.
Maybe
It just
where
all disappeared.
where
eh?
the stickers?
Let's go here. Wait. Oh, maybe I did this wrong.
There. There,
Is that
that's
it?
it.
There it is.
That's it. That's it.
Excellent. We're back on track. Okay, folk, do not panic. There's no challenge to this. Everything's under control. All right. So there we've looked at the range median. I explained the quartiles and the quartile range. Now let's look at my challenge question. Here's the challenge question, folk. And listen carefully. If you can answer this, then you understand everything you need to about statistics or about calculating ranges, means, and medians, and modes, and things. Let's have a look. A set of data consists of 7 numbers. Arrange the numbers from the smallest to the largest using the following information. The minimum value is 17. The range is 23. The median is 35. Quartile 3 is 42. The interquartile range is 20. The mode is 22. And there are 3 numbers in the mode. And the mean is equal to 42. Okay. One of the numbers is 45. We're going to make one change. They're not 7 numbers. There are actually 9 numbers. Okay. So a set of data consists of 9 numbers, not 7 numbers. That's
9.
important. So I'm sorry about that error.
Yeah.
Again, what can I do? My producer, we can just
We
only
can
apologize.
just, yeah, no, we
she's-
already know
anyway.
about her. So.
All right, so a set of data consists of 9 numbers, and back to that information, the minimum value is 17, the range is 23, median 35, quartile 3 is 42, the interquartile range is 20, the mode is 22, and there are 3 numbers in the mode, the mean is equal to 42, one of the numbers is 45. Sure, that's a lot of information there. Guys, like I said, if you can do this, you're phenomenal. So you start working on it, and hopefully
Yes.
you will be throwing the answers
Yeah,
to
please
Kat
throw
very
the
shortly.
answers to me, and I'll be sieving through them, and at the end we'll go through it. Hey.
Hopefully we will.
Yes, sure.
Absolutely. Okay, let's get on with today's lesson, and it was new question. Here it is. The graph below indicates the percentage of medals won at the Olympic Games from 1948 to 2008 for Australia and the United Kingdom. The results for 1984 have been removed due to boycotts by major participating countries. All right, so at some stage in 1980 and 1984, bit of political turmoil, and as a result, we've taken those figures off this graph. Okay. I thought this is a great question, especially because we've just
Yeah.
had the
The
Olympics.
Olympics.
Comrades,
Yes,
man,
yeah,
isn't
no,
that a
it's the
chance?
Olympics.
Okay. So let's have a look now at the data that's been given to us. Okay. So when we look at it, there it is. It fits on the screen, and let's read that. So the percentage of total medals won by the United Kingdom and Australia from 1948 to 2008. Now, guys, you can see that this graph consists of funny little things here. Squares. Oops, let me just get a nice color. Squares. And then we also have little triangles. Okay. Now, if we look at the key at the bottom, we're told that the squares are Australia and the triangles represent the United Kingdom. So just looking at that, then, what we can conclude is this, that in 1948, United Kingdom had round about 5.5%. They won about 5.5% of the medals. Australia, on the other hand, won just over 3% of the medals. The very next Olympics in 1952, we can see that both Australia and the United Kingdom won the same number of medals, just over 2%, or just under 2.5% of all the medals that were won. Australia won just under 2.5% of them, and United Kingdom also won just under 2.5%. Okay, let's go to the later figures in 2008. If you look at 2008, you can see here that United Kingdom and Australia won close on the same number of medals. But from that diagram, you can see United Kingdom won just slightly more than Australia would have done. And they're both just under 5%. Okay, so that's the graph we're looking at. Now, let's answer some of the questions that go with that. Right, so my first question is this. In which years did the United Kingdom and Australia record their best results? Okay, so let's find it. United Kingdom, when did they have their best results? So what are we doing? We're actually looking for the triangle, because United Kingdom is represented by that triangle. We're looking for the triangle that's at its highest. Okay, so let's find it. So over here I have a triangle. Okay, let's get another nice bright color. Black doesn't go on black, I've discovered that. Okay, and here's another high one. They're both around about 5.5%, and that's about the highest United Kingdom have done. So their best bet is round about 5.5% of the total medals won. Now, let's find out Australia. And you can see that straight away, can't you? Just stands out. There she is there. 8%. It's the highest little square block on that whole diagram. So Australia had a good year, 1956, when they won round about 8% of their medals. Okay, next question. According to the graph, for how many Olympic Games did Australia win more medals than the United Kingdom? So we want to know how many times, if I had to put it in simplistic terms, we want to know how many times is the little square higher than the little triangle. Now that's been very simplistic, but we're saying how many times is Australia, which is represented by my little rectangle, higher than the United Kingdom, which is represented by my triangle. So rectangle, triangle. How many times is the rectangle higher than the triangle? Okay, so let's go for it. So first thing, not this one. This one's the same, so it's not higher. Here's one over here. Okay, again, let's use a different color other than black. There she is. Over here is another year. They're the same. In 1968, the square is bigger. In 1972, the square is a little bit lower. 76, it's a lot lower. 1988, it's lower. 1992, it's higher. 1996, it's higher. 2000, it's higher. 2004, it's higher. Okay? And in 2008, it's slightly lower. So I'm not going to circle that one. So we've got 1, 2, 3, 4, 5, 6, 7 games. In the last few years, since 1948, 7 of those games, Australia won more medals than England actually won. Okay, not good news for England, I'm afraid. But I wonder what happened this year. Do you know that final figure? I didn't
No, I
see
don't know it, eh?
Okay.
We'll find out, though.
All right. But great that South Africa won so many medals.
Yes.
I was quite chuffed.
We did
The total of 6,
fantastically.
wasn't it?
Yeah.
That's not bad, eh? Really good. Right. Now, the following data in the table shows a percentage of gold medals won by countries hosting the Olympic Games compared to when they attended the Olympic Games in another country. So let's have a look at that. So what they're actually saying is this data now represents the following. We are looking at what countries hosted the games and how many gold medals they won when they hosted. At the same time, we're saying, well, when they weren't hosting, how many gold medals did they win then? Is there some sort of pattern building up here where one could say, you know, if you are hosting the games, you're advantaged? Or is this data going to reveal, you know what, you're actually better off if you go to another country? Or is this data going to say, you know what, we don't know whether it benefits you or whether it doesn't? Let's have a look. So Australia, when they hosted the games, they won 31 medals. When they weren't hosting, on average, they won 30 medals. United Kingdom, they won 13 medals when they were hosting. When they were not hosting, they only won, they won even more, 30. But that does not apply to this year, folk, all right? This question was actually developed before the current Olympic Games, so I just want to put that out there. Okay. Now, Italy, 36% of the gold medals when they were hosting. When they weren't hosting, 34%. Right. Japan, 55% of their medals when they were gold when they were hosting, 32 when they weren't hosting. Shame, look at Canada, hey? That must have been really frustrating for them.
Ooh,
they were
yeah.
hosting the Olympics and they won
nothing.
No gold medals.
That must have been pretty bad.
That must have been pretty embarrassing
Yeah.
for them and really, really frustrating for the coaches.
Yes,
okay.
of course.
But when they go to other countries, they win 25% of the gold medals, which is phenomenal. United States of America, 44% when hosting, 23% when not hosting. So it looks like United States of America, the Americans really get
They
behind
did.
the athletes. Eh?
Yeah.
China, 51% gold medals won when they were hosting, 33% when they were not hosting.
Because there's so many of them, I guess.
All right. What, so many gold medals? Or
Yeah,
so
of
many
course. So many,
okay. All
so
right.
many everything.
Okay. How many countries, when hosting the Olympic Games, won more gold medals compared to when an Olympics game in another country? Okay. So I'm going to, here we go. I'm just going to try and find the next graph, and it makes it easier flashing between these two screens. So let's do that. Right. So when did they win more games when they were hosting? Well, Australia won more. Let's get a nice color. Australia won more. Italy won more. Japan won more. Canada definitely didn't. United States did, and so did China. Guys, from that bit of information, I would say that when you are hosting, or when a country is hosting the games, it seems they're at a greater advantage. Okay. Right, our next question. Our next question states the following. How many countries that attended the Olympic Games in other countries have a higher percentage of gold medals as part of their overall total of gold medals compared to when they were hosting the country games? Well, it's just going to be the opposite question, isn't it? Now they're saying, well, when did they get more gold medals when they weren't hosting? Well, guys, it's quite simple because it must be the other two countries, United Kingdom and then, of course, Canada. Okay. Right, next one. Calculate the average percentage of gold medals won by the countries that hosted the Olympic Games. I'm going to come back to that question, all right, because I think it's time for an ad break. Before we do have the ad break, I'm just going to run through our challenging question again, just very quickly, so that during the ad break you can do it. The question was, you got 9 figures. The minimum value is 17. The range is 23. The median is 35. Quartile 3 is 42. Interquartile range is 20. The mode is 22. There are 3 numbers in the mode. The median is equal to 42. One of the numbers is 45. Okay.
Awesome.
Time
Thank
for a
you,
break.
Peter. That's fantastic that you went through it. And remember, if you do have questions on the challenge question, don't be afraid to ask, guys, because we are here to help you. So perhaps if you want to ask a thing or two before you actually dig into it, make sure that you do that right now. See you after the break.